Hello, my name is Professor TK the Chemist, and today we're going to get into a problem that a lot of students have for General Chemistry 2 that deals with acid-base calculations, specifically titrations. So let's go ahead and get into this first problem. It says a 30.0 milliliter sample of acetic acid of unknown concentration is titrated with 0.100 molarity sodium hydroxide. It takes 22.5 milliliters of sodium hydroxide to reach the equivalence point. What is the molarity of acetic acid? First thing you need to do is look at your chemical reaction, make sure it is balanced. If it is balanced, good. If it's not balanced, take care of that part first. Now, the other thing that you want to do is to make sure that if you have a 1-to-1 ratio, this will be a simple step of using the following chemical formula, and that is this one. The molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Why do we say we can use this particular formula? Well, because when there's a 1-to-1 ratio, you do not have to worry about coefficients. So let's see if this problem is properly balanced. Let's take a moment to make sure. So now what we need to do, because this reaction is already balanced, what we're going to do is go ahead and label our chemical reaction. So what they told us in this problem is that we have 30.0 milliliters of acetic acid. They also told us that we were working with 0.100 molarity of sodium hydroxide with 22.5 milliliters of that. So what you're going to do, because this is a 1-to-1 ratio, you're going to go ahead and multiply the molarity of the base times the volume of the base, and then you're going to divide that by the volume of the acid. So my formula becomes Ma, because you're looking for the molarity of your acid, that's equal to the molarity of your base times the volume of your base divided by the volume of your acid. All you need to do is plug in the numbers here, and the numbers are going to be 0.100 molarity times the volume of the base, which is 22.5 milliliters. Now, normally you want to make sure that your volume is in liters, but in this particular case here, your milliliters units are going to cancel out, so there's no need in converting. Now, your volume of your acid is going to go on the very bottom, which was the 30.0 milliliters. You're going to go ahead and cancel out your milliliters, and we're going to plug this into our calculator. So we've got 0.100 times 22.5 divided by 30.0. And in this case, we get 0.075 molarity. That is your answer for the molarity for acetic acid. It's that simple. Now, this was easy because it was a 1-to-1 ratio. Suppose you have one where the coefficients are different, where the ratios are not 1-to-1. What would you then do? Well, let's take a look at problem number 2. Here is problem number 2. It says a 15.0 milliliter sample of nitric acid is titrated with 0.050 molarity of barium hydroxide. The equivalence point is reached after 18.6 milliliters of barium hydroxide is added. Find the molarity of nitric acid solution. All right, here we go. In this problem, it is already balanced, but I also noticed that my ratios are not 1-to-1. Now, anytime you look at your coefficients right here, based on the acid and the base, if they are not a 1-to-1 ratio, then you're going to use the following formula. You're going to take the moles of your acid times the molarity of your base times the volume of your base, and say that's equal to the moles of your base times the molarity of your acid times the volume of your acid. You're going to rearrange the problem to look for your unknown of one of those 6 variables. In this case, they're wanting us to find the molarity of nitric acid, so therefore I am going to solve for the M of A right here, the molarity of the acid. So I'm going to rearrange this problem, and I know that I'm going to have N of A, okay, the moles of A times the molarity of B times the volume of B. That's going to go on the very top, and on the very bottom, I'm going to have the moles of B times the volume of A. That is going to be equal, that's going to equal to your molarity of A, okay? Or the molarity of your acid problem. So they gave us 15.0 milliliters of nitric acid. It was titrated with 0.050 molarity. And they also told us 18.6 milliliters of barium hydroxide. So what I know is that I was given my molarity of my base and the volume of my base, and the moles of the acid is equal to 2. That coefficient 2 right there in front of HNO3 are the moles you're going to use for your acid. So I'm going to say 2 times the molarity of the base, which was 0.050, times the volume of the base, which is 18.6 milliliters. We're going to divide that by the moles of your base, which is 1, because see, there's an imaginary 1 right there, all right, in front of barium hydroxide, times the volume of your acid, which is 15.0 milliliters. Again, all you're going to do is cancel out your milliliters, and let's go ahead and multiply everything on top. So we've got 2 times 0.050 times 18.6, and then we're going to divide that by 1, which is, still that number again, divided by 15.0, and we get 0.124. So the molarity of your acid of HNO3 is 0.124 molarity for nitric acid. These problems don't have to be hard. If you just look at what you got, these will be easy as 1, 2, 3. All right. If you want another problem, make sure you comment acid base below, and we'll hook you up with another practice problem. All right. Good luck in your General Chemistry 2 studies.